arrange the following in the decreasing order of reactivity towards the SN2 reaction. And you have been given four options A, B, C and D. So to solve this particular problem, we must know the factors which affects the rate of the SN2 reaction. First is alkyl iodides are most reactive towards these reactions, followed by the alkyl bromide and then the alkyl chloride. So all are the bromides in that case. So the first factor is not applicable to this particular question. And the second one is the primary alkyl halides are most reactive towards the SN2 reactions, followed by the secondary, while tertiary is the least reactive. So you see this is secondary in nature alkyl halide because it is this bromine is connected with the carbon which is connected to the two again carbon. So this carbon is secondary. On the same ground, this carbon is also secondary and D is also secondary, but this C is the tertiary carbon. So this should be the least reactive towards the SN2 reaction. Benzyl halides are most reactive towards this SN2 reactions, followed by the allyl halides and then the alkyl halides. This is the most important thing which will decide, right, the course of the reaction. So here you can see double bonded system. This is, but it is a diene. So definitely the where you have the double bond, whether it is in the form of the benzyl form or the allyl form, they must be most reactive towards the SN2 reactions, right? So since this option B is having the two double bond, it is a conjugated diene type of the system. So in that particular case, the transition state which will form in the SN2 reaction, the pentavalent transition state, this would be more stabilized due to the delocalizations of the electron, and this delocalization basically in the transition state weakens this Br bond. Okay, so this should be the most reactive, right? And followed by the this one B, D is also having your double bond, so this will again stabilize the transition state pretty well, but in comparison to the B, that transition state would be less stable. So this B should be the most reactive, followed by the D, and then your A, because it is secondary in nature, and tertiary should be the least reactive. Okay, and then if I draw the structure for this compound C, you can see it is the bicyclo compound and it is the bridgehead position, and at this bridgehead position it is almost impossible to have the what we can say the transition state, right? Planar transition state is not possible in that case. So two factors are actually operating against the SN2 reaction for this particular compound. First is it is tertiary in nature. Second, you will not have the planar transition state, while this planar transition state will be very, very beautifully achieved in case of the B, and then finally by the D. So your correct option is B is the most reactive, followed by the D and then the A and the C.